Hi everyone, let's have a look at this question. Okay, feel free to pause it and see what you think and play it when you feel like it. Okay, let's have a go. A block of mass m lies on a flat rough surface. The coefficient of friction between the block and the surface is mu. The surface is initially horizontal and its inclination is gradually increased. When the inclination of the surface exceeds 42 the horizontal, the block begins to move. Find mu. Okay, and the inclination of the surface is increased further to 44 degrees. Find, in terms of m, the magnitude of the contact force between the block and the surface. Okay, so first of all, let's draw a diagram. So let's just say there's a horizontal and this block is moving, the rough block, and there's the block, this is treated as a particle, onto this rough horizontal. So that weight drops down mg. Now that is Rn, the contact force, and this runs perpendicular to the slope. So this angle is, let's say, is treated as 42 first of all. So that's 42, and that's going down, so that's going to be mg cos 42 downwards, and going along here, going down the slope, it's going to be mg sine 42. Okay, and what we got in this case is limiting equilibrium, where the block begins to move. So when it starts to move, we know that mg sine 42 is equal to friction. Okay, they're in equilibrium. It's starting to move. So we should know that also that friction is equal to mu times the contact force. That's when it's at its limiting equilibrium, it's maximum. So in this case we got mg sine 42 is going to equal to mu times mg sine cos 42. So we want to find mu, so we divide it through. So we got mg sine 42 over mg cos 42 equals mu, and they will cancel, and therefore that will be the same as tan 42. So if I put in my calculator tan 42 to freezing figures, well, it's giving me 0.90040, so that's going to be 0.900 to freezing figures. So we can just say mu is 0.9 at this point. Okay, so that is mu. Now it's telling me that the inclination of the surface has increased to 44 degrees. Okay, let's go back and change all those to 44. So and now if that's 44, so I'm going to put 44 there, that's going to be coming down. That's 44, that's 44. Okay, that's 44. So what I've got is that's coming down, that will be coming down, the angle is steeper, and what will be opposing it will be friction. So in the equation that's coming down in terms of m, in In terms of n, the magnitude of the contact force between the block and the surface. Okay, so now that was A. Part B. So n, the magnitude of the contact force. Okay, so first of all, let's just see what that's coming. So that's friction. So from this time, so friction is going to be 0.9 times the contact force, which is going to be mg cos 44. Okay, yeah, so that's going to be the friction. So mg 44 times that. Right. So we know that the magnitude of the contact force is, so let's put contact force. It's going to be, let me just get that off. It's going to be friction squared plus Rn squared square root. Okay, so we've got in this scenario, we're going to have, so we know that the Rn, just put in here, so we got that in terms of m. I'm just going to put, yeah, let's do it in terms of m. We're going to get 0.9 times 9.8 times cos 44. So we got 6.34, could do 5 m. Okay, that's the friction, and the Rn is going to be just mg sine cos 44. So that's just going to be 9.8 times cos 44, which is just going to be 7.050 m. So if I want the contact force, the magnitude of that, I'll get 6.345 squared plus 7.0. Well, actually put the m there too, and put 0.050 m, all that squared, then square rooted. So that's squared plus 6.345 squared, we'll get 89.954 m squared, which all needs square rooting. So if we square root that, we get 9.48, and square root of m squared is m. So in terms of n, the magnitude of the contact force is 9.48 m.